Okay, so this is page 11, and on page 11, we're going to go over similar figures. Now, a similar figure is a figure whose angle measures are all congruent. Congruent means equal in measure, but whose sides are proportional. So they are very similar to scale models. They basically they look like they are the same shape, exactly proportional, but one is bigger than the other. So in this first example, we see a rectangle who has a width of 1 and a length of x, and they're telling you that a similar rectangle has a width of 9 but a length of 108. So if they are proportional, that means I can put width over length, and I could put the width of the large triangle, 9, over the length of the large triangle, 108. And that's going to be proportional to the width of the small and the length of the small. So I set up a proportion. 9 is to 108 as 1 is to x. I get 9x equals 108. Divide by 9, and that answer is 12. Okay, so let's look at the next one. Again, they say they're similar, which means that the width of the small is to the length of the small, as the width of the large is to the length of the large. So this is pretty obvious because 5 over 5 has to equal 25 over 25. So this answer is 25. Now, let's look here. And it's here again, I would say 70 is to 120 as 7 is to x. And here, if I divide both by 10, it's obvious that x equals 12. Okay, so we can set up proportions of similar figures to find the missing length. And that's what we did here on page 11. Now, we're going to turn to page 7 and try to do a problem there. So let's turn to page 7. Okay. And I have to get this bigger, so let me try to move this. Okay. So on page 7, it says a right triangle has leg measures that are 4.5 by 1.5. Okay, so you remember that a right triangle looks like this, and the right angle is opposite what's called the hypotenuse. Okay, just to do a little review. The other sides of a right triangle are called the legs. So this is saying that the legs are in a proportion of 4.5 to 1.5 meters. So the lengths of the legs of the second triangle are proportional. So that means they would be similar. So which could be the lengths of the legs of the second triangle? So the way we're going to do this is we're going to say 4.5 is to 1.5. Now I'm going to try to simplify this. I'm going to multiply the top by 10 and the bottom by 10. And then I'm going to simplify to 3 over 1. So we have, this is in a proportion of 3 to 1. So I want to see which of these are in a proportion of 3 to 1. So A is 6 over 2, which is 3 to 1. So we're going to say A is an option. B is 8 to 5. Well, 8 to 5 is not 3, so B is not an option. 7 over 3.5 equals 2, so C is not an option. 10 over 2.5 is the same as 100 over 25, which is 4, so D is not an option. And the last one, let's make some room to show work. Okay, the last one is 11.25 over 3.75. And I want to know if this is in a ratio of 3 to 1. And I think it's going to be easier to multiply than divide. So I'm just going to do 375 times 3 and see what I get. If I get 1125, then it is. So this is 15, carry the 1. This is 22, carry the 1. Carry the 2, sorry. And 3 times 3 is 9. This is 11. So it is 11.25 or 3.75 does equal 3. So E is also a possibility.